Good morning. Lori here with a little bit of information about regression. So first of all, remember regression is the tool that we're going to use to identify whether there is a relationship between the independent variables, the variables that we think might affect our dependent variable, which is the thing we're trying to predict. So I've got some Best Burgers data for location number 54, which is right down by the stadium. And I've gotten data that talks to me about whether or not, if it's a work day, a game day, whether or not we have full staff, and whether or not people can use a 25% off coupon. And I have that all related to sales for the day. And what we're going to try and do is predict sales based on these four other variables. And these are called dummy variables because they don't actually have values, but we can assign values to them so that we can use them in a mathematical equation. So in this particular case, if it is not a work day, we've assigned the number 1, and if it is, we've assigned the number 2. That way we can tell as we move from low to high that whether or not there's a relationship between it being a work day or not and sales. So you can do a regression with just one variable, and I'm going to quickly do one for you. And a regression in Excel is extremely easy, but you're not responsible for that in this course. I will, however, post a video on how to do regression in Excel, just in case you're interested, but it will be in the supplemental section and it will be optional. So I'm going to hit regression, and I'm going to be predicting my sales. So I pick my Y variable, and what I want to predict is sales. And the X variable that I'm going to use, we decided would be my 25% off coupon, just as an example. And we're going to hit return. I want to hit OK because I've got it all pre-set up, except of course it doesn't like me today. There we go. Let's try we've got too many dependent variables, that's why. All right, sales. And here are my regression results. And before you get discouraged because there's so many numbers on this page, please don't, because there are only a few that you care about. And the ones you care about are significance F, and you want this to be less than 0.05. And that's because you want to be fairly sure that the model that you're looking at and the numbers that you're looking at didn't happen just by chance, that there really is a relationship between the variable or variables and or the independent variables and the dependent variable. And we can quickly determine, I know that that's less than 0.05 because that's an e to the negative 105, but one quick, easy way to do it is to do conditional formatting, highlight cell rules, greater than, and I put in 0.05, and I just hit OK. And if it's greater than 0.05, it will turn red. In this particular case, it didn't turn red, so that's good news. I'm going to give that a yellow. This is telling me that I can explain 29%. I flip it over to percentage by just clicking on that. I can explain 29% of the variance in sales by whether or not people can use a 25% off coupon that day. And I can tell you that it's a positive relationship because as we go from 1, which is no you can't use the coupon, to 2, which is yes you can use the coupon, my sales increase because this coefficient is a positive number. So usually though, and in this particular case, we wanted to look at whether or not all of these variables could be used to better predict sales. So I've done that, and I did a quick regression, and here are my results. I've looked at my significance F, and I found that it is 0. And look at that. With these 4 variables, we can explain 75% of the variation in sales. That's a huge number and very, very good for a regression. One of the problems I've spotted, though, is down here. I've done the same thing with conditional formatting that I did with significance F, as you can see, and I put in 0.05, and sadly, one of my numbers has turned red. So that's telling me that workday, whether or not it is a workday, has absolutely nothing to do, a 95% chance it has nothing to do with whether or not the amount of sales I have that day. So I need to get rid of that. And so I reran the regression without workday, and I got a significance F, which is good, of 0. I'm still explaining 75%. And let me do these p-values. You don't need to do the p-value for the intercept, but you do for the for the independent variables. And I'm going to put in 0.05, and nothing turns red. So I now know that all three of these have significant impact on my sales. The question is, significant impact, that's great, but how much of an impact? And that's how why I have copied this up here. I'm going to do it again, paste it, and I bring my coefficients up here so that I can make my prediction machine. And this little formula or set of formulas that I'm going to put together and show you how to do will allow you to predict what your sales will be. So our objective here is predicted sales. Predicted sales. And widen that out just a little bit. Now the value that I always put in for my coefficient is 1. And but let's decide, is it a game day or not a game day? Well, if it is not a game day, then we want to put the number 1 because it's not a game day. So let's go back to that. If 1 is not a game day, how about we don't have full staff? That's a 1. And how about you can't use a coupon? So we have 3 1s in a row. And those are the values we're going to put in. Our impact is going to equal the coefficient times the value. And I can just copy that formula down. I sum those up using my auto sum feature, and I've got projected sales of 6,154 that day. So let's go over again real quickly how I did this. I copied my coefficients up here. Then I put in the values for what I thought might be happening that day, and I calculated the impact, which is the value times the coefficient. And in this particular case, if it's not a game day, if we don't have full staff and we have only 20, and you cannot use a 25% off coupon, then we are only going to have 6,154 in sales. Let's go all the way to the other side and say it is a game day and we do have full staff and you can use a 25% off coupon. Well, our sales are going to jump according to this prediction machine to $11,240.77, and that is absolutely how it works. So with regression, you find the relationship between the variables, and that's what's represented in these 2 boxes. Then you use the expected value for each one of those independent variables, and these are the ones that we can change. I'm going to highlight them in orange, and these are my inputs, so I'm going to highlight those in orange. And this is a formula. All of these are formulas, so I'm going to put those in blue. And this is a formula. And we've got a very nice prediction machine that we can use to predict sales under any number of circumstances. So let's do one last one, which is, let's say that it is a game day, but we don't have full staff. Somebody screwed up the scheduling, and you can't use the 25% off coupon on that particular day. That drops our sales down to 7,561. So it looks like it's really important whether they can use that coupon, and of course whether or not we have full staff. And that's it for this video. I'll give you lots of practice in how to do this stuff. Thanks for listening.